Now in this video, I've got a square wave pulse, 5-volt peak. I've got a 200 ohm resistor in series with a 5 microfarad capacitor. My output voltage across my capacitor will have this shape. This side of it is my rising edge, and this side of it is my falling voltage. So I've got my rising voltage right here, and this is my falling voltage. My frequency is 20 hertz, and my maximum current equals 25 milliamps. Now, I'm going to find my RC time constant. My RC equals 200 ohms times 5 microfarads. And that equals that equals 1 millisecond. Now my pulse width, right? My pulse width is 500 microseconds, and it takes another 50 milliseconds from the end of my pulse until it starts my next pulse. As my pulse goes through, I'm going to have a 5-volt maximum falling across my 200 ohm resistor. 5 volts over 200 ohms, that will give you 25 milliamps. Now, what about my voltage across my capacitor? I'm going to use my pulse width of 500 microseconds and my RC time constant of 1 millisecond, and I will find my maximum voltage across my 5 microfarad capacitor. So I'm going to use my formula. 5 volts times 1 minus E, and my exponent is negative. Now my pulse width is 500 microseconds, so I'm going to put 500 microseconds here. My RC time constant equals 1 millisecond. And I plug this formula into my Casio. and I get a peak voltage across my capacitor of 1.96 volts. So my peak voltage equals 1.96 volts. And that is my peak voltage across my capacitor, and this formula is for my rising edge. Okay, now what about my falling voltage right here? The formula for the falling voltage is 5 volts times E, and my exponent is negative, over T over 1 millisecond. This is V out, and I'm going to put an F here for falling voltage. This is V out, and I'm going to put an R here for rising voltage. Okay, now we have a problem here. And the problem is that this is only 1.96 volts, right? It's not 5. So what you have to do is you have to find at what time that 1.96 volts would occur if this voltage actually went up to 5 volts. And the way how you find that time is to use this formula right here. You go 5 volts times E over T over 1 millisecond equals 1.96 volts. Now you take this formula and you solve for T. And T equals, I'm going to plug this formula into my calculator. And I get a time of 936 microseconds. Okay, now, so what does that mean? That means that when I'm finding my falling voltages, T is greater than or equal to 936 microseconds. So when I'm finding my falling voltage, my T is greater than or equal to 936 microseconds, and that will give me the voltages along the falling voltage curve right here. So this formula is the formula for the rising voltage right here, the straight line. And this formula is the formula for the falling voltage right here. And this brings me to the end of the video. Subscribe, like, share. Subscribe, like, share. Thanks for your attention.